Hello, hello. It's that time of year again, hoodie weather. I hope that wherever you are in this big bad world, you're having a good time. Things are going well for you. But it is also time for a new spooky software video. I'm really excited about this one. This is something that I think sort of in the client-side rendering space, that is to say JavaScript apps that run in the browser, kind of SPA architectures, people are excited about. I'm personally excited about, and I'm definitely excited to share it with you. So let's dive into it without further ado. So today we're going to be demonstrating a technique called render as you fetch. You probably have seen this around, and it sounds newfangled and fancy, and it somewhat is. It's simplistic in conceptually, but it's a little bit difficult to implement, maybe until very recently. So here we go. I've got this little demo app, right? And this is very standard sort of client-side rendering architecture. And in this particular video, we're going to be totally focused on sort of the SPA architecture where, like for instance, if we view the page source of this thing, there's no HTML here, right? The server is just sending us basically an empty body with a little tiny bit of script, and some kind of like JavaScript application is going to take over. This is sort of the standard bread and butter of a React application, a solid JS application, or whatever. This is sort of the default. Of course, it's got routes, right? And so the idea is I've got this navigation over here, and I've got a few pages I can go to, and I've got this home page, which, doesn't have any data or anything, and it's very tiny, and that's great. But then I've also got some pages over here that have some data on them. And so I can quickly demonstrate here. Okay, so I've got this thing, and this particular app is fetching GitHub data. It's fetching repositories. So these are all my Git repositories on GitHub, and displaying them to the user in this nice table, right? And I've purposely induced in today's demo, all of the asynchronous calls that we're going to look at have additional induced latency. So they're going to take about 2 seconds minimum each. And that's just so that things are easier to see. Since this is all happening either locally on my hard drive or GitHub, which generally is pretty fast, things are probably a little too fast for the recording and or your eye to pick up on, so I've induced some latency here. So that's why you can see, okay, if I refresh this page, this is like really slow. That's all this induced latency. Okay, but there's something else going on here, right? Which is in the console, I've displayed some things that are kind of letting us know what's going on. And you can see that like when I refresh this, okay, so first of all, we're like fetching a lazy component, which we will get to in a moment. And then like some amount of time later, we're actually fetching those GitHub repos from GitHub's API. And you can see that to actually display content, the amount of latency, the amount of time until the user sees something is like those two numbers added together. And so this is generally what we refer to as a waterfall effect. And that's important. We will come back to that in just a moment. So let's look at the actual source code of this. This is very, very normal, very standard if you've ever written a client-side app in your entire life. This is kind of the root application. This is the JavaScript that runs on the page load and starts rendering stuff to the user, right? So we tell React, hey, render inside this component and render inside this element, and we have a router, right? And this is, generally speaking, the giant switch statement, the giant if statement that says, if I'm at the / route, I want to render the home. If I'm on some other route, I want to render this fetch as you render route. If I'm somewhere else, I want to do this one. And, finally, I don't know where you are, you're at 404. Okay, great. This is very, very normal, right? So let's actually look at the source code of this fetch on render. And this fetch on render is actually very standard. This is how maybe up until like, a year ago or something, this is sort of how everybody wrote their sort of data-driven application routes, right? Like pages within their app would be kind of written this way. So let's go take a look at this route. You can see it's at / fetch on render. And we're using here React's built-in suspense. If you're not familiar with suspense, it's not that important for the conceptually of what I'm demonstrating here, but the important part is React has built-in support for lazy loaded components. You can see that I'm actually calling import as a function here. So this is sort of when the user goes to fetch on render's route, I would like to dynamically download that JavaScript. And this is really important when you have huge applications with many, many pages and many, many features. You don't want the user to download all the JavaScript for all the features. You can kind of do it on demand. Generally speaking, we call this code splitting. It's more of a feature of your build system than it is of your JavaScript framework, but the two work together such that in this particular case, React can understand that this element is async. The JavaScript that's associated with it needs some time to download. There's some templating in there. There's, whatever this component is doing, in this particular case, displaying a table of GitHub repos, that's asynchronous. And so this suspense here is saying like, well, while you're waiting, show a loading indicator, right? And of course, all right, so great. Now we've got some lazy loading code splitting. So the idea is that like the user doesn't have to download all this JavaScript when they come to the page. They only have to download the fetch on render code when they actually navigate to fetch on render, right? Okay, so like let's look at the content of this. And again, this is very, very standard, right? Almost every client-side app is going to have code that looks like this inside of it, which is, okay, once this component mounts and starts rendering, it's going to make a query. And again, this get repos function is that asynchronous call, that asynchronous fetch call to the GitHub API to fetch the JSON data. And then, of course, we have to handle the loading state, show some kind of loading indicator while we're waiting. And then finally, once we have the data, we can actually show the table and, the page itself, right? So let's go back to this again. I just want to demonstrate this. So again, notice that, okay, there's this lazy download, right, of this code split. And then sometime later, there's this fetch GitHub repos, and you can see that they're in serial. There's this waterfall effect. And that is specifically because before we can start fetching GitHub repos, we have to download the component that tells us to fetch those repos. Like this line right here is in fact the line that is telling us to download the repos, make this API call to GitHub. So we don't know we need to do this until we finished downloading this entire component. And so this is kind of fetch on render, right? We start fetching as soon as we render. And if your render is also asynchronous, my goodness, you're going to start adding up these latencies in serial. Okay, not so good, right? What can we do instead? Well, there's actually a variety of ways to do this, and I think that, maybe in the modern React world, there's kind of, for instance, V18 of React, there's suspense for data loading, which may also be another way to kind of solve this problem. Or maybe if you're using a different library altogether for your server or your client-side rendering, like if you're using Solid or something, maybe you have something else. But what you can do today, without any support from your JavaScript framework, is you can do what's called render as you fetch. And so I'm using a feature of, in this particular case, the React location router. Most of these solutions are going to have some kind of marriage between your code and the router, because ultimately the router, the thing that looks at this URL and says, oh, it's time to render this particular page, is going to know enough information to get this stuff going in parallel. I'll show you what I mean. So here, if I click on render as you fetch, you can see that actually both, that got confusing here. Both the async element and the GitHub repos fetch started immediately in parallel. And you can see that the actual page, instead of taking 4 seconds for the user to see, only took 2 seconds, because basically both of those asynchronous operations take 2 seconds. Let's see that again. Like, okay, 1 Mississippi, 2 Mississippi, right? Whereas here, it's 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi. Wow, okay, big difference. How did I do that? All right, so now let's take a look at the render as you fetch route. You can see it's kind of similar, right? We've got a path. We still have this delayed asynchronous element. You can see we're dynamically importing an element. So that has to happen. The router has to have support for asynchronous elements. We're not using React suspense here, as you can see, and that's because React location specifically has support for something that returns a promise. And so we can just tell the router, hey, like while this element is outstanding, show this loading indicator. And then we also have support for an additional func callback called loader. And the router can say, okay, well, I know that this is an asynchronous element, and I know that this has a loader callback, which in this particular case returns a promise. You can see we're doing a fetch query for, again, those repos. The router sort of, at the moment that you arrive on a route, as soon as you navigate there, can start both the loader and the element at the same time in parallel. So like just as a real quick, again, just to kind of concretize this in your mind, you can see when I refresh this page, I started both right away. And that's because the router called this function and started this element fetch at the same time. And the router is able to do this because you told it how to do that. So there is a bit of coordination between the component that's inside here, this lazy component, and this line, because you have to tell the router, here are the things that this component will fetch when it finally finishes downloading and starts rendering. So this is where this render as you fetch kind of idea comes from. And let's just kind of concretize that. So this is the actual, I apologize. This is the actual component, and it's almost identical to the other one. The only difference really is that we don't have a loading state. We actually know, because we configured it in the router, that by the time this renders, data will already be there. There is no if is loading at all. And again, this is exactly the same content, more or less. It's just showing these repos, right? So this kind of idea is how you get around this waterfall effect. Is you coordinate your lazy components with the data that they will require in a place that you are able to start both in parallel. And in this case, we're using the router. There's one final feature I kind of want to show off, which is just kind of more of this in, kind of taking it to the logical conclusion, if you will, is that of course, routes can have children, right? So again, I'm at the render as you fetch route, but if I click on a sub route, where in this case I have a sidebar. This is again some more asynchronous data. This is like some data I'm fetching from GitHub about my profile, right? So here's all the repos and here's the profile of the person, right? So if I do a refresh of this, you can see that actually I've kicked off 4 things all in parallel, right? So I've got this asynchronous element, which is the, repos outer shell. And then I've kicked off the fetch for the GitHub repos themselves. I've kicked off another asynchronous operation, which happens to be this sidebar. And I've also kicked off an asynchronous fetch for user bio. And all of that happened in parallel, right? All of these took 2 seconds, but the same 2 seconds. If we sort of did this in the classical way, where once this finishes loading, we start loading this asynchronous element, which makes a data fetch, and that would be in serial, this would take 8 seconds or something for us to get all of this data on the screen, whereas from here it's just 2. And again, this is all coming down to some tight integration between your code and the router. The router knows just by looking at the URL that you will need this, and you also, through these loader functions, told it which data those components will need when they actually start rendering. And again, I'm just gonna take a brief look at that code just so you can see. So here's this sidebar. Again, it looks exactly the same as the sort of parent component, where we're lazily loading the content, the template, the component itself. And we're also telling the router, here's a function I want you to run to sort of prime this component for when it's ready. This is the data it will require. And again, the router is smart enough to know I got to wait for this and this before I display anything. There's one final thing I kind of want to touch on, which is related, but not exactly the same thing. One kind of cool thing that we did here is, both of these components that are using this loader function at the router level, they don't have to handle loading state at all. There's no if loading here. They just render assuming that the data will be there. There is one kind of cool thing here, which is because the loader, because you've configured the router to know what data to fetch, it can start doing that almost at any time, right? So for example, if I refresh this, I don't have this demonstrated, but I can kind of talk through it, which is, this is a link right here. If we just look at this, here we go. It's an href, and inside that href is, of course, a URL, which is /s. The router, for example, you can write a component for a link tag that's like, as soon as the user hovers on that element, it can start prefetching, because it knows that, hey, if the user actually does actually interact with this thing, I already know which component they're going to need, and I already know which data that component is going to need. I can start that right away. So you don't even have to wait to start that 2 seconds when you click, right? You can just bam, and before you even click, the router is capable of knowing what to do, right? Furthermore, there's also a little kind of cool thing going on here as well. This is related. This is just a user experience thing, which is when I click on this, you notice that the page doesn't change right away to the loader. There's like a brief wait, right? So let's take a look at that. This is actually a configurable thing for my particular router, which is I can say, how long do I want to wait before I show pending state? So in my app, we've got this kind of placeholder thing. The router can wait to display that for some amount of time. This makes the app, it's not actually any faster, but this is like a user experience thing where if your asynchronous component and its data load quickly enough, then you don't even have to show a loading state at all. And again, I can demonstrate that pretty easily. Async. Let's go delay here. So instead of 2000, I'm just going to go, well, I guess we can say 0, right? And I think there's one other place if I look. Yeah, this guy. We'll just say 0. So I'm taking away the delay from all of these asynchronous calls, so they should be fairly quick now. Components should almost render instantly because they're right on my hard drive. So if I'm on home and I click render as you fetch, you can see that it holds the previous home. I'm not sure how well this is showing up in the recording. Let me do that again. So I'm on home, and this will kind of stick around for just a moment when I click on this, because the router is holding the previous route before showing the new one. So the user doesn't even see a loading state. So this kind of provides it's not actually any faster. It's still the same amount of time from when I click this button, but it feels faster to the user because they don't actually see this flicker of a loading state. And again, you can kind of configure your router to say, well, how long before you show a loading state? And so if the data, all these lazy components and the data from GitHub takes less than 1 second, the user will just not see a loading state at all. So, this is really, really cool stuff, and you can do this today. The tools are out there. It's a little bit, you kind of got to hodgepodge together your own tools. I don't know if there's a completely cohesive experience out there from the ground up. You gotta have a router that presumably supports this, and presumably supports it with sort of nesting, so it knows all of the data and all the components for all the routes and sub-routes that you will be loading. And you also probably, however you're fetching your data through Fetch or React Query or Apollo or whatever, you have to have a little bit of support for prefetching and these kinds of things to integrate with the router. But it does exist, and you can do this today and make your client-side rendered apps even faster. Now, one thing I didn't touch on at all, which is sort of server-side rendering. This is kind of another way to fix this sort of waterfall latency thing. And again, that is going to work the same way, except on the server, which is the server, as soon as it gets a request, is going to start all of these data fetchings in parallel using some kind of server-side ready router that, again, knows all of these nested data loaders and whatnot. And again, maybe I'll make another video kind of demonstrating that separately, but this is something you can do today right in your client-side app. Well, this has been great. I hope you enjoyed it. I'll put this up on GitHub as usual. And I hope you have a great day.